Number 23. Here you've got a tennis ball launcher and a tennis ball, and they want to know how fast the launcher is going to move backwards. So it's this equation right here, just in reverse. You've got mass of the launcher and mass of the ball, both of which have a velocity of 0 in the beginning. So, I mean, this is the initial part. In the end, then, you have the mass of the ball that's given. You have the final velocity of the ball. What you don't have is the final velocity of your launcher. Here is your question mark. So if this stuff is all given and it equals 0, then this side must also equal 0. So you multiply the momentum of the ball, and you have the mass of the launcher, and your question final velocity of the launcher, and you'll solve for the v final of the launcher. Looking then at 26. In an elastic collision between two objects, do both objects have the same kinetic energy after the collision as before? They don't each necessarily have the same collision. It's that the total energy of both objects before equals the total energy of both objects after. If, let's say, both objects have 50 joules of energy before the collision, afterwards maybe it's 70-30. The big idea being that both objects have a total of 100 joules before and 100 joules of energy after. That's the big idea for 26. On 28, two cars with masses of 4 and 3 kilograms move towards each other on a frictionless track with speeds of 5 and 4 meters per second. They stick together, find the final speed. This is exactly this equation. You're given mass of 4, speed of 5, mass of 3, speed of 4, but they're going towards each other, so one of these has to be a negative velocity. So you'll take that. Let's see, 5 and 4 is 20, and 3 and 4 is 12. 20 minus 12 would lead you to have 8 on this side. 8 equals 4 kilograms plus 3 kilograms, which is 7 times v final. So 8 equals 7 times v final. Divide 8 by 7, and your answer is 8/7, whatever that comes out to in the calculator. It's going to be the answer for that one. That's 28. Looking at 30. Got a railroad car with mass of, what is that, 20,000 kilograms, moving at 3 meters per second, hits two cars, so that's 40,000 kilograms, moving at 1.2 meters per second. Find the speed of the three together. Again, this is the same equation. So you got 20,000 times 3 meters per second and 40,000 times 1.2 meters per second. So you add them together, you got 60,000 VF, and solve for VF. That's part A. Part B says find the decrease in kinetic energy. So now what you have to do is you have to find kinetic energy of the first car, so 1/2 mv squared of this one, plus 1/2 mv squared of the two cars here. And that's going to give you a certain amount of energy. Then over here, you're going to have 1/2 of 60,000 times your final velocity answer, and that's going to be a smaller amount of energy. And what you have to do is you have to take that energy and subtract to find the difference. That's 30. 32, you got a 5 gram coin, put that in kilograms, moving at 25 centimeters per second, put that in meters per second. Makes an elastic head-on collision with 15 gram coin going at rest. After the collision, the 5 one's going 12.5, find the final velocity. Elastic collision, so they bounce. So MVI plus MVI equals MVF plus MVF. Solve for final velocity. And then find the energy transfer to the 15 gram coin. So they're saying, energy gets transferred from one to the other. So find the initial energy, 1/2 mv squared, of the 15 gram coin. And then compare that to the final energy of the 15 gram coin with your final answer. For number 35, you got a momentum question where they give you the momentum, they give you the mass of the baseball, and they want to know what velocity. So just momentum equals mass times velocity. So take your momentum, plug in your mass, and divide your mass over to solve for the velocity. Number 36. A moving object has a kinetic energy of 150 joules and a momentum of 30 kilogram meters per second. Find the mass and speed. This is one of those equations that, or one of those problems like you get in math class sometimes where you have two different equations with the same variables, and you gotta solve. And there's music playing in the hall, so I'm gonna stop this recording.